All right, so let's get started. Hi, everybody. Thanks for coming. So today we're going to talk about Docker for developers and ops, and I'm going to give you an update on what's new and what's next. So a little bit about myself. So I'm Patrick Chanezon. I'm French, but I've been living in the US for more than 10 years. I spent 10 years in my career building platforms at Netscape, AOL, and Sun, and then 10 years evangelizing them at Google, VMware, Microsoft, and I joined Docker a year and a half ago. While I was at Google, I created the developer relations team for cloud when it started with Google App Engine. Then I moved to VMware to do Cloud Foundry and Spring. And at Microsoft, I was focused on driving Linux and Java workloads to Azure. So as I told you, I've been in the US for 10 years, and so I'm an American citizen now. And I've been pretty depressed at yesterday and what happened. It seems like we're living in a Simpsons cartoon dystopia from 2000, or bad Back to the Future, wrong timeline story. But I hope as a nation we'll heal. The motto of the US is E pluribus unum, which means together we make one. So I hope the next 4 years are going to be better than this election. Let's us guess. So why did I join Docker? In 1995, I started using a browser, and at that time I was building client-server applications, so I tried Netscape. And there I really realized there's a new way of building applications with HTML pages rendered on the server side and instead of building client-server. And when I discovered Docker in 2015 while I was at Microsoft, I just realized this is the kind of tool, it's as revolutionary as the browser, and it really helps me build my applications in a different way. And Docker is the kind of tool that grows on you. The more you use it, the more you start thinking about different ways of doing the things you were doing before. So that's what drove me to Docker. On the other hand, one thing I wanted to say, for those of you who are old enough to have been through several technology cycles, I think I've been working for 20 years in software now, so I've seen at least 2 or 3 of these cycles. I definitely think technology is moving in cycle, and I feel like that hamster in that spinning wheel. Like every 7 to 10 years, we have a complete change of architecture, and then we're going back to after 2 cycles, we just go back to the old IDs. But it's a growing spiral where the number of machines and the size of the data that we're manipulating are bigger all the time. So in the 60s, everything was centralized in mainframes. In the 80s, we went to client-server, typically Windows operating system or OS/2 on the client, and then a big Oracle database on Solaris on the back end. In the 90s with the web, I think we really went back to the mainframe architecture, where if you think about it, the browser at that time was as dumb as a VT100 terminal, and everything was happening on the server. And right now with cloud and mobile on one side and the new HTML5 web browsers, both mobile and modern web browsers are as powerful in terms of the primitives that you can use to build applications as client-server desktops were. So I think we're really going back to a client-server architecture between the client and the server. But here the server is a distributed, horizontally scalable cloud-based microservice architectures. So why was Docker so successful? That's my view on the market, and I'm using movie analogies to explain the position of the different players. So to me, there are 2 areas here. On the left, you can see private or data center-based workloads. That's where people were in the past 10 years, and it's mostly virtualized, and VMware is dominating in there. And then on the right, you have the 3 big cloud providers who are duking it out right now for market share with Amazon, Microsoft, and Google. And in terms of and what's been happening in the past 3 years is that after dragging their feet for many years, enterprises start to move to public cloud and to build hybrid architectures. And I think that's one of the reasons that explains the success of Docker. So in terms of movie analogies for the different players, I would say VMware is like the movie 300. I don't know if you saw it. It's the story of 300 Spartans that are resisting an army of 10,000 Persians. They're very courageous. They shout Sparta, but then at the end they all die. And to me, that's kind of where VMware is today. I don't know if you saw, they did an agreement with Amazon to try to milk the cow for a little bit longer, but I don't give them much long to live in that transformation. Then you have Amazon, and to me, they're like Independence Day 2. It's a really bad movie, but there's one great line in there. There's a spaceship that's the size of the Atlantic who lands on the Atlantic, and one of the generals calls the President of the United States, and he says, oh, they landed on the Atlantic, and he says, where? And he says, everywhere, because the spaceship is as big as the Atlantic. And to me, that's exactly the effect that Amazon had on the enterprise market, where they started to land in the enterprises with their massive cloud that nobody can match. Google, to me, is like Back to the Future. So my friend Alexi, who's working at Google, says I exaggerate a little bit. Maybe a little bit, but just a little bit, I would say. So why is it Back to the Future? While I was at Google, I was trying to sell a version of App Engine, which is a PaaS App Engine for business, to companies. And when I started talking to them about that, I think it was around 2010 or 11, they just laughed at me. They said, we want portability, we want to have hybrid architectures, we certainly don't want to put all our data at Google, and we don't want to use a PaaS. And to me, Google is like Marty McFly, the hero of Back to the Future. In the first movie, he goes back in time in the 50s, and there, in an evening, he starts playing rock and roll to them, and they don't know rock and roll yet, but they're ready for it. So everybody's dancing, and they're very happy about it. But at the end of it, he starts playing hard rock, which is music from the future, and then there's a big silence, and nobody understands that. And to me, that's pretty much the attitude of most enterprises when they see Google technologies. It's technology that's coming from the future, but people are not ready to use yet. They have some really interesting stuff like BigQuery and things like that, but they don't run inside the firewall. And so people are very wary of putting all their data in there. So to me, Google needs to create a better transition from where people are today to using their tools. To their benefit, I have to say that what I've seen in the past 2 years that they've been doing, especially with things like Kubernetes, I think they're going in the right direction, but there's still a lot of work to do. So to me, Microsoft is like Terminator 2. In the second movie, Terminator comes back, but he's the good guy this time. And the Microsoft... yeah, I know that would, at a Java conference, that would make people laugh. When you see the Microsoft of Satya Nadella... so actually, Satya was the first guy who interviewed me when I joined Microsoft. And after the interview with him, I called my wife and I said, yeah, I'm probably going to join these guys. He knows what he's doing. So Satya's coming from Sun, he used to be a member of technical staff at Sun before joining Microsoft. And one of the things that you have seen at Microsoft in the past few years is a broad adoption of Java, Linux, and more generally all the open source technologies. So the Microsoft of today is very different. To me, Microsoft has a very interesting strategy where they really bet on hybrid from the start. So with Azure, they're trying to catch up with Amazon with lots of different data centers around the world and a pretty powerful and fully featured cloud. And they have a parallel on-premise story with, I think it's called Azure Stack. So something that you can buy, run internally, and has the same API as Azure. And then on top of that, in the middle of all that transformation, you have Docker. And Docker is a technology that's being used both by devs and ops. It helps people adopt a DevOps workflow, and it provides that level of portability between the different clouds and on-premise that enterprises are looking at when they want to not be completely locked into one of the cloud providers. So I think that explains a lot of the success that Docker had, and The movie I'm using is Charlie and the Chocolate Factory, because we're building great chocolate that everybody loves. Okay, so what does the stack look like nowadays? At the bottom, you have your virtualization or cloud provider, sometimes bare metal. So the big ones are VMware, Azure, Amazon, and Google Cloud Platform. Then at the operating system level, there's been a very interesting transformation in the past 3 years, caused by Docker. It started with CoreOS, where they realized that in the data center, when people want to run microservices, the only thing they need is a Linux kernel and Docker. And so CoreOS started with a very reduced Linux distribution that has very little things in it and just a Docker engine to run all your workloads. So you're putting all the dependencies of your application and your microservices inside of containers. Very quickly, the whole industry followed suit. So Red Hat has Atomic, Ubuntu has Ubuntu Core. Rancher OS is one of my favorite because they went Docker all the way. They're even running system services in a special second instance of Docker for system Docker. Photon by VMware, and the most interesting one is Microsoft. So Microsoft is known for Windows Server. A lot of enterprises are running that. And last month, Microsoft announced Docker with Windows containers. So what they've done is that the isolation features that Docker relies on in the Linux kernel, they created similar isolation features in the Windows kernel for Windows 2016, and they re-implemented a Docker backend for Windows containers. So they announced that last week or last month at the Ignite conference. And in addition to Windows Server 2016, they have another version of it that's called Nano Server. That's a shrunk-down version of Windows Server without any UI. You manage it with PowerShell. And it's really designed to run workloads with high density at scale in data centers. So then on top of that, you have Docker Engine. Our philosophy is batteries included, but removable. So we have a set of plugins for things like volumes and networking. And then what you see on the right is orchestration. And over the last year, there's been a big battle between many orchestrators. I'd say the three main ones are Docker itself. So with Docker 1.12 and Swarm mode, Docker now has orchestration built in. The Kubernetes project that was started by Google and has a very big community behind it. And the Apache Mesos project, which is older and was kind of well established for people using big data and was kind of revamped for scheduling containers as well. But you have a whole host of others like Cloud Foundry, who's reinventing itself as a container orchestrator. So why do people adopt Docker? To me, there are two main drivers. The first one is agility for developers, and agility has been around for quite a while now. The Extreme Programming book is from 1999, and I'd say today in most enterprises that I meet, developers have adopted Agile. And it's not for the sake of developers, it's really about the business, and there are some business drivers to adopting an agile methodology. I think Adrian Cockcroft summarized it the best when he talked about lowering what he calls the MTBAMSH, the mean time between idea and making stuff happen. Agility is really about having developers iterating faster and creating features as opposed to building infrastructure. And so it's really about dollars and making developers more productive. The second trend is DevOps. It's a younger trend. It's like 5-year-old now. And it was actually created in Belgium initially. Since the mainframe era, devs and ops had, let's say, a very conflictual relationship. In the client-server era, it wasn't much better. Typically, your developer wouldn't talk to the Oracle sysadmin who was managing the Oracle database. In the 90s, it was even worse. I remember at Netscape, we were using Java and C++ to create our applications, and the ops were only using Perl, so they didn't understand anything about the workloads we asked them to run. And with the cloud era, devs and ops started to work together using the same methodologies and tools, and it's called DevOps. So DevOps is more a cultural movement than anything. It's about people, processes, and tools. It's not only about tools. People and processes are very important there. And it's about teams adopting common practices like continuous delivery, infrastructure as code, collaborating between silos, doing small iteration, and doing lots of measurement in order to improve the product. So it's about that feedback loop. But DevOps, like Agile, it's not about singing Kumbaya. It's at the end of the day, it's about the dollars. And where are the dollars here? If you look at that, at these numbers, in 1999, a Windows sysadmin would manage 5 machines. A Linux sysadmin, Linux was always better at automation, would manage 50 of these machines. In 2015, in large companies that are fully automated, like Facebook or Google, a single sysadmin typically manages 10 to 20,000 machines. So we're growing the ratio of machines managed by a sysadmin by 2,000, and that goes with a lot of automation. You're obliged to work at a high level of abstraction if you want to do that, and you need to standardize your infrastructure. So, as I said, DevOps is also about people and processes. I highly advise you to watch the talk by Henk Kalk, who's an IT manager at ING, and he explained in this DockerCon talk in DockerCon EU 2014, he explains how ING adopted a DevOps approach by starting to reorganize their department completely. They had to fire a lot of people. They mandated that everybody becomes a developer, so in order to build infrastructure, you needed to build that as code. And so infrastructure was checked into the GitHub repository and all that. But that started with a reorganization. So if you want to adopt DevOps in your enterprise, start to take a look at people and processes. It's not only about tools. So let's talk about the Docker platform. At Docker, our goal is to build tools of mass innovation. That's our mission statement. And what we mean by that is that we identify technologies that are useful for people to start innovating, and we make them easy and accessible to use. And very often when people are talking about containers, they just realize if you're looking at the history of containers, they've been existing for a long time, from BSD jails to Solaris zones. But what Solomon succeeded into doing in creating Docker is to make them easy and accessible. And that's when they became useful for everybody. So what kind of tools of mass innovation are we building? The first one with Docker is we're trying to make the internet programmable. What we mean by that is that there are lots of devices coming online with different capabilities, and in order to program them today, you need to run in different silos. Whether you're programming for your drone, or for an industrial control system, or for a robot, or for a big cloud platform, or internally inside the firewall, typically your development models need to be different. You're using different tools and APIs. The goal of Docker is to build that distributed OS that would run the same way everywhere, so that you can build your applications in a single way. So how are we going about it? We create what we call that stack. That starts at the bottom with standards. So here I'm talking about the Open Container Initiative that Docker started with 40 different companies, pretty much everybody in the industry. So OCI is really about standardizing the runtime and image format for containers. And then on top of that, we have what we call infrastructure. So infrastructure are components that you can use that are very low level and that you can use to assemble your own systems. So here we have things like runc, which is the reference implementation of OCI, and that's the piece that's running containers in Docker. But we also have containerd, VPN kit, data kit, and hyperkit that are components that were used to build Docker for Mac. We have swarm kit, that's the basis for swarm mode in Docker. And more recently, we released InfraKit, that's about building self-healing infrastructure. I'm going to talk a little bit more about this one. So as you see, when Docker evolved, at Docker, we're building a full platform. Solomon Hykes gave a keynote at LinuxCon last month where he explained our approach, where it's like Linux but with a twist, where instead of building the kernel, we started by building the distro, the full product for developers and ops, with very opinionated UI. And then out of it, we extract these plumbing components that compose the kernel. So at Docker, we started with the distro, and then we're going towards the kernel. So on top of that, we build a development platform that's Docker, and then on top of it, we have commercial products, and I'll talk a little bit more about that. But this is what keeps the lights on at Docker. So Docker is based on isolation primitives in the Linux kernel, namespaces and cgroups. The same kind of primitives exist in Windows, and so Docker runs both on Linux and Windows. Another innovation that really made Docker successful is that notion of image layers. So in Docker, we're using a union file system where you can create images with a certain base, and then on top of it, you just put the diffs of the things that are different from the base image. Which means that if you're on a server and you run 15 different applications that are based on Ubuntu, the Ubuntu layer will be downloaded only once, and then the layers on top of it are pretty thin. And then on top of it, you have a copy and write file system for your container itself. So Docker for developers, what does it look like? Typically, you would inherit from one of the images that comes from Docker Store. So it can come from Docker Hub, which is for community images, and then Docker Store is for validated images coming from either commercial providers or official projects. So you inherit with a from directive, so that's what a Docker file looks like. Here I'm inheriting from Java 7. Then you have directives like copy that let you copy files from your file system inside of the container image. Then you can set a working directory for the next commands, and you can run commands. Here I'm compiling my code. And then the CMD directive says which command is going to be executed when you run your container. Once you've done that, you do a Docker build. -t lets you specify a tag for it. And dot is like in the current directory, is going to look at the Docker file and the context. Once you've done that, you can run your image with Docker run. -it lets me specify a terminal that I want a terminal. -rm, I want to destroy the container when it's done. I can assign it a name. So that's what running a Java application in Docker requires, just writing a Docker file, compiling your code and putting it inside of the container and specifying the arguments to launch your service. Then there's one aspect which is, for developers, one of the important things is that you could use Docker as well to compile your application. So here is an example by mounting the current path inside of the container and then compiling my code in there. So this is a more realistic example using Maven. So if I do a Docker run of the Maven container. Here I can compile my whole application by mounting the current directory where my code is and my pom.xml inside of the container, of the Maven container. One trick for Maven that is pretty useful to know is for Maven, you don't want Maven to re-download the whole internet every time you compile your code. And since containers just disappear after you've run them, the .m2 local cache, local Maven cache, you want to mount it inside of a Docker volume. So before you use Maven, you do a Docker volume create Maven, and that will be a volume that you use for all your Maven runs, so that your Maven cache will be in that volume. And then you write that out to that directory, and you do a Maven package in there. If you want to analyze images, you can do Docker images Java to analyze all the to see all the Java images you have on your Docker engine, and then Docker history shows you how the image was built. In order to build an image, it's Docker build -t with the tag of the image and a dot for the current directory or the directory path. So this is an example of a Docker file for an application that I'm going to show you where it's a simple Spring Boot application that's using MongoDB. So here, what I'm doing is that I expose port 8080 to run it. I copy the jar that I have compiled using the Maven command that I showed you before inside of my container. Then I set the working directory to that directory. And then I do a java -jar of my jar and passing it some arguments like the server port to expose. And then the MongoDB URI that I need to pass as an environment variable. Now, for that, I would need to have a MongoDB database running, and I need to pass to my container the MongoDB URI to it. So how do I do that? So typically, I would run it like that, docker run. I pass an env variable with the IP address of the MongoDB database, and I can map some external port to the internal 8080 port. Now, when I want to run that, I don't want to have to install MongoDB on my development machine, especially with microservice-based applications. Typically, you may have from 3 to 10 different microservices for a single application. So you use a compose file for that. Compose files let you define the set of services that your app is composed of. So here I have the web service. It's my Chanezon Spring Doge image. I explained the ports that I'm exposing here, and I have a second service for Mongo, and here I'm just using the Mongo image. So that would be a development version. For a production version of it, I would add some volume mapping for the Mongo data, so that the Mongo data is stored either on the host or on a remote file system. And here what you can see is the links. Links allow me to link one service to another. So here, because I linked the web service to Mongo, when I'm inside of the web container, if I curl or connect to the Mongo host, it's going to connect me to the Mongo service. And you can see that now I can pass my environment variable MongoDB URI with a Mongo name there. So that's pretty portable. So let's see a demo of that. So I'm going to show you that Spring Boot application app using MongoDB. And I'm going to show you another app that I'm going to, I just want to show you how you can debug your application inside of Eclipse, debugging an application. So let's take a look at first the Spring Doge application. I'm just going to open this guy. Just to show you the file structure, so here I have a few Docker Compose files. I have a Docker file that I showed you before. Yeah, I think that's big enough. So in that Docker file, I just copy. Also, that Docker file actually is doing the compilation, is doing the Maven install, and copying the jar inside of the container in a single shot. I'm using that Docker file for continuous integration. So on continuous integration, I want the CI/CD system to be able to compile all my code. But for development, I'm using this one where I use the Maven container in order to compile my code into a jar file, and then I do a Docker build of that Docker dev file to copy the jar in the right place and run that service. When I've done that, I can use that Docker Compose file that I showed you before. And let's try it here. So if I do Docker Compose -f Docker Compose run.yaml up. So it's just going to start my Spring Doge. It's going to create my Spring Doge Mongo service, and then it's going to launch my Spring application, my Spring Boot application, and it's going to connect to the MongoDB database. And because I'm on Docker for Mac, so here, Docker for Mac, to install it, you just download it from Docker. It's a DMG. You just drag and drop Docker into your application path. And when it starts, you get this little whale icon here where you can see about Docker. You can set some preferences in there. So here I can restart my Docker engine. I can set some advanced things like insecure registries or mirrors or proxy settings. I can map files in there. But basically, once I install, it just works. One of the benefits of Docker for Mac is that it's deeply integrated with the Mac system, with the underlying Mac system. And so, for example, for networking, all the network calls on the Linux VM are translated using a TCP/IP stack that's coming from the Mirage OS project back into Mac calls so that the Mac thinks that these calls are coming from itself. And that allows Docker for Mac to work well with a VPN. The file system mapping also is much more efficient than the one in VirtualBox. VirtualBox shared folders were very slow, so when I mount a volume in Docker for Mac, the performance is much better than with VirtualBox. And so the team in Cambridge that's working on Unikernel has been very active into creating Docker for Mac. Justin, who was giving a talk, and who's sitting there, who was giving the talk on Docker security, has been pretty involved in that. So because the networking is integrated, now I can go on localhost 8090, and my application will be running there. So it's a simple Spring application where I can drag and drop an image into it, and it's going to call a REST service that is going to add some stuff to the image and then store it into MongoDB via MongoFS and Spring Data. And so it's adding some gobbledygook like that. So it's an application from Phil Webb and Josh Long from Pivotal, with whom I used to work before. Okay, so that application is running. Now, I just wanted to show you an example of how to do debugging of a Docker application. So here I'm going to use a different application that I have set up in Eclipse. But let me show you the structure of the application. So here I have a simple Java application that lets me register a user and log into a server. And so the source code is in there. So I have a user class, user sign up, a controller, a model, and all that. And so it's a web app. So I have the source code for the app in that directory. And then I have the registration database, which is, I think it's, let's take a look at the Docker file. Yeah, it's a MySQL database. So I have a Docker file for MySQL and for filling the MySQL database with sample data. And then I have a registration web server, which is a Tomcat 7 on Java 8 server. That is, so the important piece here is that. So I set GPDA options to let another process debug applications in that Tomcat instance on port 8000. And then I expose port 8080, which is the port where the application is running. So that's the Tomcat setup. And I have a Docker Compose file that puts all these together. So here I have a database service with my MySQL instance running on port 3306. Then I have the web server, which is the one I told you about. And this guy is important, the volume. Here I'm just mounting my app directory where the code is going to be compiled by Eclipse inside of the Tomcat container in the web apps directory. So the result of that is that my user sign-up application is just going to be served from the directory where I compile it. And I do a link to the registration database. And I open this time the port 8000, which I'm going to use to debug my container from inside it. So here what I can do is I can do a Docker compose up. Oops. So that should start Tomcat as well as the MySQL database. And then once I've done that, I can go into Eclipse. So I've set up a project there, and what I want to show you is the run config for all the debug configurations. So here I have created a debug configuration for a project called user signup. I do a standard socket attached to it on localhost on port 8000. And because my compose file is starting Tomcat and opening the GPDA port to 8000, I should be able to start debugging that application right away. So let's try that. Oops. So it failed to connect to the... So let's see if this guy is started. Yeah, it is started. No, it's not this guy. It should be. I must open what, sorry? Oh, so I did open port 8000 here in my compose file. I opened port 8000 there. Oh, I see. Yeah, I see what you mean. So here I should expose port 8000. Oops. Oh, it's weird. It used to work yesterday. So let's try. I know it doesn't want to run it. Let me check if I don't have anything. Yeah, so 8000 is actually exposed here on the registration web server, so that shouldn't be the issue. Okay. Close socket connection. Oh, that's weird. Yeah, we have 21 minutes, so I won't debug that for you right now, I think, because I have other demos I wanted to show you. But all that, tutorial is available on GitHub. So it's github/docker.com. github/docker/labs. So if you go there, you'll see some tutorials for Java development, and this one is in Developer Tools Java debugging. And so there you have instructions for how to set up Eclipse for debugging, IntelliJ, and NetBeans. Yeah, I just want... let me try once more now. Sorry? Oh, actually you're... Oh, thanks. All right. Yeah, actually I prepared that demo before, so that's it. It's already connected. So let's try to go to localhost 8080. So there I should see my application. Yeah, let's go there. Yeah, I think it's manager off. Okay, what's the password in that? I think it's somewhere in there. It should be in my compose file actually. Blah blah blah. Oh no, it's in my compose file. Sorry. Yeah, so when I'm starting that, it's I have the MySQL root. Oh no, I don't know. No, I think it was different. Maybe it's in that guy. Oh, I see. So there's a. Yeah, thank you. Oh, so it's admin. Ah, how original. All right, so if I get there, oh no, access denied, no. What? I'll just go to user sign up. I'll just go directly to the application. Okay, so here I have my application, and there I can create a user like foo bar 123 foo bar. It's born yesterday. foo@bar.com. And then when I submit, do you want to do this? Yes. And here my breakpoint is set up, and I can look at variables, and I can start debugging my stuff. So I just won't go through the whole demo of showing you the bug and all that. I'll just switch to another demo. But essentially, you can use Eclipse to set up debugging to debug your container directly. So let's talk about... So yeah, if you want to do some labs, in the lab section that I told you about, Arun Gupta created a great tutorial for how to use so the example I showed you is a Spring Boot application. Arun created a G2EE application with Wildfly and Couchbase. And it's all detailed into that Docker Labs tutorial. So now let's talk about what's new. So first, on the developer experience side, we think at Docker that the best tools get out of the way, adapt to you, and make the powerful simple. That means Docker for Mac and Docker for Windows. And in terms of orchestration, we added swarm mode in Docker 1.12, where orchestration is built in. And what that means is that when you do a Docker swarm init on your Docker engine, it switches into swarm mode, and then you can do a Docker swarm join from another node to join that swarm. It has cryptographic node identity, so by default it's secure and TLS enabled on both sides or on any communication. And each node has its own certificates that are auto-generated by the system, and you can set up a policy to determine how often they are rotated. There's a new service API, so you can do a Docker service create. It's a declarative API. You just declare what your service should look like, what container is running, how many instances you want. And Swarm is going to continuously reconcile the state across the cluster to make sure that the constraints that you ask for are in effect. And then the last thing in Swarm mode is that built-in routing mesh, where when you publish a port on a service, and so when you create a service and you publish a port, what Swarm is going to do is that it's using IPVS on the nodes, on each of the nodes of the cluster. A port will be chosen for exposing, and it will be load balanced automatically. Which means that if I created my service there, and I exposed port 8080 mapping to 8080. Port 8080 would actually be open on all the nodes in my cluster, and then when I reach any of the nodes, IPVS will load balance me to one of the services running in the swarm. And then what you can do is at an additional level, you can add a layer 7 load balancer that just talks to these nodes. But it's much easier to set up. So if you're using Docker 1.12, it's already in there, so you can do a Docker swarm init and Docker service create. The last thing we enhance is the ops experience. So lots of sysadmins are setting up Docker on a cloud infrastructure, either Amazon or Azure. Docker for Amazon and Docker for Azure are in beta right now. It's a private beta, so you need to go to beta.docker.com/docs, and you sign up to get access to it. And once you get access to it, you can deploy it on either Amazon or Azure. And what these editions are, they're deeply integrated Docker setup, deeply integrated with the underlying platform. So for Amazon, for example, it's integrated with ELB for load balancing. It's integrated with CloudWatch for the container logs. It's integrated with your SSH keys, your access control, your auto-scaling groups. And I'm just going to show you how it works. The last thing I wanted to talk about is that new distributed application bundle. So that's a portable artifact that you can generate from a compose file. It's an experimental format for now. It's not complete. But basically, when you have a Docker Compose file that describes several services, you can do a Docker Compose bundle, and it will generate that JSON file that has the SHA signatures of your images and the port that you need to open. And then you do a Docker deploy, talking to a swarm mode cluster, and it will just deploy and create your services. I'll show you how that works. So let's do a demo of Docker for AWS. But before I do that demo, I wanted to, actually, while doing that demo, I wanted to show you, so what I'm showing you there, it's kind of an idea of where Docker is going with all this. This is a prototype. It's not available outside yet, and I don't know which form it will take and when it will ship. But in that prototype, we have a version of Docker for Mac that's integrated with Docker for AWS through Docker Cloud. So here you can see I'm logged in with my Docker ID. So my Docker ID is the ID I'm using when I'm connected to Docker Cloud or Docker Hub. So Docker for Mac knows who I am in terms of a Docker ID. And here I have a new menu, Create Swarm. And I'm going to create a swarm on AWS. So that redirects me to AWS console, where I have a CloudFormation template that corresponds to Docker for AWS. When I click Next, I can specify a stack name. So let's take Pat Docker Devoxx 3, because I have created 2 already. I'm going to create a swarm with 1 manager, 2 nodes. I'm going to use a small instance for the manager and a micro for the nodes. It's integrated with my Amazon key, so here I can choose my favorite SSH keys. And this is the new option there. Here I can assign a swarm name, which is going to be the namespace swarm name that I want Docker Cloud to serve me. So I'm going to use that as Chanezon Devoxx 3. Here I can put my my Docker ID username and then an API key that I'm getting from the Docker console. So if I go to Docker Cloud onto my account, I'll see an API key. I'm just not going to do that here because I've done that a little bit before. It takes 5 to 10 minutes to deploy. But once it's deployed, what's happening is that my whole, the CloudFormation template is going to deploy an auto-scaling group on Amazon. So the number of managers that I want, the number of workers in that auto-scaling group is going to set up, actually, let me show you what it sets up. So that's the one that I created before. So the create is complete here, and what you can see in terms of resources. So I have a load balancer that's set up for SSH, a load balancer that's set up for outside resources, and it's using CloudWatch for the logs, and it's integrated with my SSH keys. And the last thing that's really special about this template that's not in the current version is that in addition to that, if I have filled these 3 forms, giving it my Docker ID, is going to register the keys for that swarm onto Docker Cloud. And then when I go there, I can say my swarms, and I'm going to see the swarm I created before. And if I click there, it's just going to create a terminal window that has all my credentials all set up. so I don't need to like source some environment files. If I do a docker node ls, docker node ls, in there you can see that I'm talking to a swarm on Amazon with these 3 nodes that I have created. So that's really super powerful to interact with Docker. Let's take a look at, if I do, actually let me, I'm just going to do a Docker service create and create a simple, oops. Oh yeah, it's here. So I'm going to do a Docker service create for a simple service that shows the load balancing power of Docker in action. So here I'm doing a Docker service create. I call that demo 1. I want 10 replicas. I publish port 8081, map it to 8080 of a eHaslet Docker demo. So if I do a Docker service ls, I'm going to see. Okay, so here I can see my demo 1. It has 10 replicas and it's running. So now when I go back to that CloudFormation template, I have the outputs here. And as part of the outputs, I have the default DNS target. So that's the target for services that are going to be exposed. And what's happening when I do that is that it's publishing port 8081 on each of the nodes in my swarm. And because it's Docker for AWS and it's integrated with AWS, there's a container in there that's part of the edition that's listening to swarm events. And when it sees that I publish port 8081, it's going to configure the elastic load balancer of that cluster to just expose 8081 and map it to 8081 on each of the nodes. And so when I run that, it should serve the application corresponding to this container. So that's the evangelizing one. And what this container is doing is that it's doing a XML HTTP request back to the same URL so that you can see the different container IDs that that have been generated for that service. So that's the Docker for AWS demo. After that, I want to talk about what we call CAS, Container as a Service. So that's our commercial offering that we build on top of Docker open source. So our goals there are agility for developers, portability for devs and ops, and control for ops. And the goal is to create an offering that enterprises can use to manage their global supply chain for software. So the CAS workflow is you're using Docker for Mac or Docker for Windows or on Linux, to build your application, then you ship them into a registry. So our commercial product is Docker Trusted Registry. And we have a whole security workflow for signing your images. And then you deploy them on a universal control plane, which is our commercial product that adds role-based access control, Active Directory integration, and things like that. So that's what it looks like. The current versions, UCP 1.1 has high availability, a unified authentication between Docker Trusted Registry and Universal Control Plane, the ability to do deployment from compose files, and a new UI to add nodes. The current version I'm going to show you is the current beta for UCP 2.0 that's based on Docker 1.12 with Swarm mode enabled. It has a pretty rich permission model from no access to view only. In our demo at DockerCon, we just gave our CEO, because we don't trust him with our containers, just view only access on a Swarm cluster. Restricted control is what you would give to a developer team. They can create their own containers and manage them, but they cannot see the containers of any other teams. Then you have full control, so that's for admins of the whole system, and the admin has additional access where they can manage users and permissions. There's an additional security service that's only in Docker Cloud for now, but that's going to be on-premise in Docker Data Center pretty soon. It's called security scanning, where when you push an image to Hub, you can elect to have this service continually scan your images for a well-known database of vulnerabilities. And this database is constantly updated, so if your images have a vulnerability, you will be notified about it, and then you can just fix it and rebuild your images and deploy them automatically. So let's do a demo of UCP. So that's what Universal Control Plane looks like. That's the latest version where I can see the nodes in my cluster, the services and the containers that are running. I can see the resources there. So if I go to resources, I'm able to create a service directly there. Instead of doing a Docker service create, I can create that from the UI. I can look at the various containers that are running in there, or I can look at volumes, networks, and applications. So what happens there is that if you go to your profile, you can create a client bundle, and that client bundle is going to download a set of certificates that then you'll use to authenticate with the Docker client with that instance. So I've done that here in that terminal window. I'm just going to stop that. I think this guy, I don't remember. So if I do DMU UCP, that's a little, if I do a Docker node ls, so here I just typed a quick alias that sourced the files that I downloaded from there. And here you can see that I'm talking to my UCP cluster. And if I do a Docker service ls, I can see all the services that are running on there. And if I go to, I'm just going to go back to my Spring Doge application. And here I'm going to do, I generated a DAB file already. So that's my DAB file. I did a Docker Compose, I did a Docker Compose bundle to create that DAB file. So that's what it looks like. I have the SHA of the MongoDB image, default network, the Mongo link, and then the port that I want to expose. If I do a DMU UCP, I'm just going to talk to UCP, Docker node ls, to just double check. And once I've done that, I'm able to do a Docker deploy of the name of the DAB file. And what it's going to do is that it's going to do a Docker network create for a network that's called default in there, that's an overlay network. Then it's going to create a service, Spring Doge Mongo and Spring Doge Web. And if I do Docker service ls, I will see these services exposed. So you have this one and this one who are starting. So that's UCP, Universal Control Plane, and Docker Data Center. I'll talk briefly about, time's up. So just talking briefly about plumbing, runc and containerd, which are at the base of Docker running containers inside of Docker 1.11. Docker for Mac, we exposed a lot of plumbing, Hyperkit, VPNKit, DataKit. I just wanted to talk briefly about InfraKit that we open sourced last month. I highly advise you to take a look at it. It will be at the base of Docker for Azure and Docker for AWS. It's a toolkit to build declarative self-healing infrastructure. Essentially, you build a JSON file and you submit it to one of these daemons, and it will just create the resources and monitor them. And the JSON file, so that's kind of how the architecture looks like. It allows for two types of resources, cattles and pets. Pets have specific names and can be stateful. Cattle are stateless and can be replaced. And InfraKit is hosting itself inside of it's monitoring itself inside of a swarm. And that's what the JSON looks like. So here it's an example, and if you go to GitHub docker/infrakit, you can see this example and follow it and compile it on your machine. This is an example with an instance using Vagrant and a Zookeeper flavor to install a Zookeeper cluster running with Vagrant on your machine. In the future, there will be instance plugins for AWS and Azure and other cloud providers. And it's something that you could use for other projects than Docker. At Docker, we're going to integrate it as a set of Docker plugins to add an infrastructure API to Docker. I think I ran over, so it's time to stop. I'm going to be available outside for Q&A, because I think I ran out of time. Thank you very much.